Jai Hind to all. Myself Dr. Neelesh Kumar Gupta. I am working as a professor in EC department at Ajay Kumar Garg Engineering College, Ghaziabad. Today I will deliver a lecture on DPSK and QPSK modulation techniques. This title I have taken from Digital Communication subject. That's AKTU subject of 6th semester. Its AKTU code is KEC 601. So from this subject I have taken this title. So I will tell you in this lecture basics of digital modulation, their types, their basic, their fundamental things. After that I will come on DPSK and QPSK particular modulation techniques. Their modulations, their demodulation, their constellation diagram, their waveforms and so on. I will deliver in this lecture. Okay. So let's start about unit number 3. So in unit number 3 of KEC 601, that subject digital communication. So in this unit, digital modulation generally will be the focus. So firstly, you should know about the basics and introduction of digital modulation. What is the meaning of digital modulation? Then various digital modulation techniques and their modulation and demodulation procedure. Then we start from ASK, amplitude shift keying, FSK, frequency shift keying, PSK, like phase shift keying. So these are the basic term. ASK, it means amplitude shift keying, frequency shift keying and phase shift keying. These are the modulation techniques. Under the phase shift keying, further we will see about DPSK, QPSK and so on. So many methods are there. So here in digital modulation techniques, PSK is having very big importance. Generally we prefer PSK techniques. PSK means phase shift keying. Then their constellation diagram. Then further after the QPSK, M-array communication system. That's basic. What is the meaning of M-array communication and so on. That's I will tell you in this lecture. So at first we will see here two types of digital modulation techniques, binary schemes and M-array scheme. In binary scheme we send any one of the two possible signals, 0 or 1 for particular duration of TP. So under the binary schemes, what? Your ASK, your FSK and your PSK will come. Simple. Amplitude shift keying, frequency shift keying and phase shift keying. It means whenever the some characteristics of carrier signal is changed as per the input binary data is called your modulation. So in amplitude shift keying, when the amplitude of the carrier signal change as per the binary input data, then ASK, amplitude shift keying. When the frequency of the carrier signal is changed as per the input binary data, FSK. FSK means frequency shift keying. PSK. PSK means phase shift keying. Whenever the phase of the carrier signal is changed as per the input binary data, then phase shift keying will be. So these are the binary scheme. Under these schemes, you can transmit 0 or 1 or two level of signal, 0, 1. You can transmit. So these are the binary scheme for binary data. Now for M-array, it means whenever you want to communicate more than 1 bit data or more than 2 levels, then it is called M-array system. So what I can write, I am writing here, we can send any of one of the M possible signal during each signaling interval of duration TB. TB means, it means you are transmitting this, so this duration is called what? TB. Okay. Now M-array, again in M-array category, M-array ASK, M-array FSK, M-array PSK and so on. M-array scheme, it means in M-array scheme you are able to transmit more than 1 bit data. So obviously you require less bandwidth as compared with binary scheme, but the error performance and their complexity will be more in comparison to binary scheme. So there is some advantages and some limitation of M array scheme over the binary. So, as per the requirement, we can use these modulation techniques, binary or M array schemes. Okay. So, this is very basically I am telling you basic, because you should know the basic. If you know the basic, then you can study all the methods in terms of their modulation and demodulation. Now, we come on PSK. Okay. So, because our topic title, lecture title is DPSK, QPSK. So, these are the PSK schemes. PSK means phase shift king. So, these are the digital modulation technique in which the phase of the carrier signal is changed by the varying the sine cosine input at a particular time. So, whenever phase of the carrier signal is changed as per our input binary data. PSK is generally used for wireless LANs, biometric and so many wireless operations. So, under the PSK, what? If we talk about simple PSK, okay, simple PSK means binary PSK. So, binary PSK means what? BPSK. So, these both are same. If we talk about simple PSK system, so it means binary PSK, BPSK. Like ASK simple, you can call BASK. FSK simple, you can call simple BFSK. Similarly, PSK like a BPSK. Binary phase shift king. Whenever phase shift or phase is changes of carrier signal as per the input binary data. So, binary means a phase change in two ways. Like if phase is 0 degree, okay, or if phase is 180 degree. So, if phase shift is 0 degree, like we are assuming it is, we are transmitting the 1. If phase shift is 180 degree, we are assuming we are transmitting, we are able to transmit the 0. So, if phase shift will be of two types, will be in two ways, दो तरह की phase shift हो, 0 degree or 180 degree, for 1 or 0 binary values. So, it will be BPSK. So, BPSK, ASK, FSK, you are able to communicate, you are able to transmit only one bit at a time. But if you want to communicate more than one bit at a time, then another system, PSK system will be there. Okay. So, after BPSK, we will see DPSK, then QPSK. Okay. So, after the some slides, I will talk about QPSK. That will be better. Now, after the BPSK, we come on DPSK, because my lecture title is DPSK and QPSK. So, I have to come here at first, okay, because the introduction of these techniques or study of these techniques is so wide. If I talk, if I teach in whole the semester for these things, then time will be less. So, it is very wide, okay, scope, area of digital communication, because in digital communication, digital modulation techniques, these are the very, very important, and so many basic concepts and theories will be there in these techniques, in each techniques. So, after the BPSK, we come on DPSK. DPSK means differential phase shift king. So, in DPSK, generally we are taking two successive bits, and we can take the phase difference of those successive bits. Okay, that's why I am what I am calling differential phase shift. क्यों? Because दो सक्सेसिव बिट्स के फेज के डिफरेंस को आप आगे एनकोड और डिकोड कर रहे हो अंडर द टेक्निक दैट इज कॉल्ड डीपीएस. सो डीपीएसके इज व्हाट? इट इज द मॉडिफिकेशन ऑफ बीपीएसके. If further some limitation of BPSK we want to overcome, then we go for at first DPSK. So, what are the limitation? What limitation you are trying to overcome here in DPSK? So, this is a non-coherent binary scheme. This is very, very important. Coherent scheme will be useful. Okay, it provides the accurate result, but complexity will be there. So in DPSK, the coherent binary modulation or demodulation techniques you can overcome here. Okay. So in DPSK, non-coherent binary schemes will be there, and this modulation scheme, which the detection process does not need a carrier at the receiver for synchronizing, for phase locking with the transmitter. That's why it is called non-coherent modulation. So coherent synchronous detection that we use in DPSK. So here there is no requirement. So this is the very big advantages of DPSK technique. Third line, also brief these two lines. DPSK eliminates the need of a coherent receive reference signal at the receiver by combining two basic operations at the time. That's the same thing. Again, synchronous detection, coherent detection technique that we use at BPSK, here we don't need. So this is also advantage. Now what we DPSK, so here input binary waveform is encoded differentially. Differentially matlab, what is meaning? The difference between the two successive bit phase difference. That's why I am calling differential. Phase shift king, this is the phase shift king. For symbol 1, 0 degree phase shift is transmitted. For symbol 0, 180. So here also this is the modification BPSK. You can transmit one bit at a time. So you are assuming here again 0 or 180 degree. If symbol 1, so 0 degree phase shift will be there. If symbol 1 you want to transmit 180 degree phase, but difference is that you have to transmit, you have to communicate the difference between the successive bits phase shift. That differential term you have to forward further. That's why it is called differential phase shift king. This is nothing, this is the modification, further modification of BPSK, and the some limitation of BPSK you are trying to overcome here. Now this is the DPSK transmitter or encoder, okay, generator you can say. So here what your binary data you can generate by using this XOR or XNOR gate, using the XOR XNOR gate. So this is B of K, this is your simple data, simple raw data, binary data 1 0 in form of 1 and 0, and one terminal what its output again goes to into the input of XNOR gate. This is the XNOR gate, and this data delayed by 1 bit dB, it means delayed by the 1 bit interval. So this BK and DK minus 1 form the DK. So this is DK, final digital data, binary data that will go to further. It is what? ये क्या है? BK और क्या लिखे अपन? XNOR. What? DK minus 1, because this is XNOR. Now we know XNOR, XOR. Okay. So 0 0 1. So this is XOR operation. This is XNOR operation. So here XNOR, it means both bits. If both the bits are same, so your output will be 1. Otherwise, output will be 0. So you can use here XOR or XNOR. Any one of them you can use for generating your final digital binary data for processing further here. Now this binary data will go to amplitude shifter. Then this data under root EB or minus under root EB, it depends upon the phase shift. If phase shift is 0 degree, then it will be under root of EB. If phase shift is 180, so it will be minus of EB. So this is our binary data. This is our carrier signal that you are generating here. So binary data and carrier signal will combine through the product modulator, and finally we will generate the DPSK signal. Okay. So here your digital binary data, it can be generated using the different means, using the XOR or XNOR tip. Okay. So this is XNOR, okay, and this is XOR. Now it consists of logic network and a 1-bit delay element interconnected so as to convert the raw binary sequence BK into a differential encoded CK. This process starts with an arbitrary bit act as a reference, and thereafter the differentially encoded sequence dk is generated by this. So dk is equal to bk XOR dk minus 1 or its XNOR. So here you can use XOR operation or XNOR operation, कुछ भी यूज कर सकते। XNOR लिखोगे तो क्या लिखोगे उसको, bk XNOR this dk minus 1, और XOR लिखोगे तो इस तरह से लिखोगे। ओके, सो you can use XOR XNOR any one of the gate for generating the final binary data. So some simple bit signal and another delayed 1-bit delay signal. Now you can also give the here assumption. So initially you can assume what your dk is 1 or 0, then you can start, कुछ तो कोई initially तो मारना ही पड़ेगा ना हमको, then we will give the truth table for that. So this is bk dk minus 1 dk. Okay, so here you can see if both are 1 initially, if I am assuming this is 1, so this is 1 is coming here in terms of dk minus 1, so 1 plus 1. Okay, so what is this, 1 plus 1 is equal to 1. Now 1 again, this is 0, this is 1, 0 plus 1 0. Now 0 again क्या गया यहाँ पे, 0 plus 0 1, ऐसे होगा। नाउ 1 अगेन, एक बार 0 एक बार 1, फिर 1, 1 प्लस 1 1, फिर 1 गया, 0 प्लस 1, दिस इज 1 0 1 0, इट मीन 0 1 0, इस तरह से चलेगा। ओके, सो सिमिलरली हेयर, बिकॉज व्हाट, क्या कर रहे हो आप यहाँ पे, बीके XNOR dk minus 1 is equal to dk. Similarly here you can write this one, this one, this one. Now phase shift, if it is 1 then phase shift is 0 degree, if it is 0 phase shift is 180 degree, then 0. So similarly here you can give also the transmitted phase, differential phase that you want to encode further here. Now this is DPSK receiver or demodulation, you can say. So DPSK receiver, it means demodulation. Now your input will be DPSK signal and output will be the your binary data. So here you are giving the x of t, DPSK, this is your DPSK signal. Okay, now it will go to further band pass filter. Okay, now band pass filter is having two parts of this signal, one is simple and another is delay by 1 bit duration, by 1 bit, and goes to our product modulator or multiplier. So these two signals, simple signal and one is delay by 1 bit. Now this is P of t, the signal combining these and go to the integrator. Integrator means what? Integrator क्या होता है? It is like a low pass filter. Always at the time of demodulation, generally we prefer what? Low pass filter as a integrator. And this whole combination, what? The combination of product modulator and integrator is called correlator. इसे बोलते हैं correlator. After that, the signal will go through the sampling process for every TB, then it will go to decision device. Decision device is comparator, it will go to comparator. Now because what you are transmitting the simple signal here, but finally what you want to generate 0 or 1. So how you decide whether 0 is coming or 1 is coming? So you have to compare two signals here. So you have to compare here your incoming signal with your threshold value. If your incoming signal from threshold value 0 volt, you are taking here threshold for 0 volt. If it is greater than this, then you can consider 1 is coming. If it is less than, then you can consider here 0 is coming. See, in this way you can detect here your original binary data, 1 or 0, 1 or 0. So always generally in digital modulation techniques, at the receiver side, generally at the last you use what? Comparator circuit, because you have to generate your binary data in terms of 1 or 0. How you decide one is coming or two is coming? So you have to set some reference parameter here, that your incoming signal will be compared to that reference, and as per the comparison you can decide whether one is coming or zero is coming. So at the receiver side, the received BPSK DPSK signal with noise is passed through a band pass filter center at the carrier frequency FC. Now band pass filter output and its delayed version of by the TB are applied to the correlator. Correlator means the combination of multiplier and integrator or low pass filter. Now output of correlator proportional to cosine of the difference between the carrier angles in two correlator inputs, and after that sampling and comparator process will be there, and finally you can recover your binary data. Now these are the waveforms. Again, as per the XNOR or XOR operation, you can draw the waveform. Okay, your initial raw input binary data and your outputs feedback by the 1 bit delay, and finally if you are combining by XOR or XNOR operation, you will extract, you will finally generate your final binary data under the DPSK scheme. So waveform you can draw. This is your binary simple data, this is carrier signal. Now you are combining this and you can generate the DPSK signal. Now we will talk about its merits and demerits. So merits is what? The bandwidth is FB, because you are taking at a time 2 bits. You are taking the difference between the two successive. Okay, so this is the very important merit is what? It does not need any carrier at the receiver side for synchronization. So complexity will be reduced. Okay, and the bandwidth also require less bandwidth compared to BPS, because at a time you are not able to transmit more than 1 bit, but you are taking at a time 2 bits phase difference. This is the advantage. Now demerits. This scheme of modulation provides higher value of probability. So probability of error will be more here than BPS. Noise interference will be more, and this technique obviously it is so complex here. In DPSK, the previous bit is used to detect the next bit, hence there is possibility of error appearing in the pairs. सीधी बात है, एक simple bit and another your delayed version you are taking here. So the possibility of error will be there. Okay. Now we come on QPSK. This is a very, very important technique. The most important modulation technique is QPSK. Okay. Quadrature phase shift. So this method come for our willingness. If we want to communicate, if we want to transmit more than 1 bit data at a time, like in BPSK, ASK, FSK, DPSK, you are able to transmit only 1 bit data at a time. If you want to increase here, so QPSK technique will be the most favorable example of. QPSK means quadrature phase shifting. It is like a DPSK signal. Instead of the conversion digital bits into series of digits, it convert bit into the bit pairs. So at a time we can transmit data in pair form, bit pair form. So 2 bits at a time. अब यदि 2 बिट्स एक टाइम आप भेज रहे हैं तो सीधी सी बात है कि डेटा रेट बिट रेट टू हाफ विच अलाउ स्पेस फॉर अदर यूजर्स, बैंडविड्थ भी कम हो जाएगी हमारी, एंड देन उसी स्लॉट में यू आर एबल टू कम्युनिकेट 2 बिट्स एट ए टाइम, जबकि हम अभी तक 1 ही बिट भेज पा रहे हैं. ओके, सो 2 बिट्स एट ए टाइम and 2 to the power 2 is equal to 4. It means 4 level. 4 level you will be able to communicate under this technique. Okay, so it is like 0 0 0 1 1 0 1 1. यदि 2 बिट एक बार में 2 बिट कितने कॉम्बिनेशन होते हैं? 4 कॉम्बिनेशन. So this is also 4 array PSK system, and these 4 these are coordinate in each other. मतलब इनके बीच का जो फेज शिफ्ट होगा that will be what? That will be 90 degree. That's why this scheme is called quadrature phase shift key. So what I said in last PPT, to increase the bit rate, we can code 2 or more bits into one signal element. So in QPSK, you will be able to communicate 2 bits at a time into one single element, into the 4 levels. In QPSK, we parallelize the bit stream so that every 2 incoming bits are split up and PSK a carrier frequency. And these all are phase shifted by 90 degree from the other or quadrant in each other. That's why it is called quadrature phase shift. So 4 signal, 4 level you can communicate here. That's why it is called 4 array PSK system or quadrature PSK system. Now QPSK modulator, demodulator. So these are the some circuit diagrams. Okay, in the form of transmitter receiver. So then you can see. But basic concept you should understand. That's very important. So in QPSK modulator, this is our QPSK modulator. So digital signal se data is there. Now what you want to communicate at a time 2 bits. So some system you have to make here. So now in the modulator side we are managing system in terms of odd and even number of bits. So firstly digital data is splitted by the bit splitter into the even and odd number of bits. Similarly, if one is even, another odd, even, odd, 0, 1, 2, 3, 4, 5, 6, 7. After that you have to split this 2-bit data serial into parallel. Then it will go to our product modulator, and this is our carrier signal that you are generating here using the local oscillator. So in one product modulator, simple carrier signal will go, and another product modulator, the carrier signal shifted by 90 degree will go. Now this signal and this carrier signal will combine by product modulator and further will go. Okay, so this is our odd. Okay, this is our even. So PSK Q I means, so this generate PSK I. PSK I matlab what? PSK in phase channel. Why in phase? Because simple carrier and simple this even bits. So PSK I along with even bits will go further. Similarly, PSK Q along with what? Odd number of bits will go further. And these are added by the adder, and finally QPSK output you will get. So this is our QPSK modulator. At a time you can generate QPSK signal. Similarly, you can also draw the waveform here. Okay, and here your phase shift in each other will be the 90 degree. Now again the QPSK transmitter like a modulator. This is in detailed form we are trying to build here. This is also simple, very simple like a modulator. So transmitter is in detailed form. यहाँ भी वही कर रहे हैं जहाँ वहाँ कर रहे थे. No difference. I means in phase, Q means quadrature. Bit splitter, then serial to parallel, then modulator, one modulator, balance or product modulator. It will combine simple signal and simple carrier. Other modulator, another signal, okay, even signal and quadrature in phase. So one carrier signal is sine and one carrier signal will be cos, because both are in 90 degree in phase. Similarly, it will go to band pass filter further for this and add up by the adder some other amplifier. Then finally this signal will go band pass filter and QPS output you can get. Now quadrature phase shifting. It means what? You can generate 4 equally spaced phases. So S1T, S2T, S3T in this type. You can generate the signals in 2 bits form. Okay. So first is your phase shift 2 pi FCT plus pi by 4, then plus 3 pi by 4, then 5 pi by 4, 7 pi, and all the phase shift in each other will be in quadrature. And generalized form of signal you can give. So here your I is equal to 1, 2, 3, 4 you can put, and you will get this equation of the signal. From these equation you can also draw the orientation of the signal in terms of constellation diagram, and this is the waveform of QPSK that you can make. QPSK demodulator. Similarly, demodulator means what? Again QPSK demodulators. Okay, again one synchronous detection here you are using. In one part you are synchronizing your local oscillator carrier signal phase frequency with incoming signal. In another part you are synchronizing 90-degree phase shift of carrier signal with incoming signal. Then it will go to a low pass filter 1, low pass filter 2, then again these combined with odd and even, it means parallel to serial converter, then by the bit splitter, and finally you will get the binary data that you transmitted from the QPSK transmitter. This is constellation diagram. It means orientation of your what? Or symbols, your bit station. Okay, so this is pi by 4, this is 3 pi by 4, this is 5 pi by 4, this is 7 pi. So similarly you can draw the constellation diagram for ASK, FSK, BPSK, QPSK and so on. So constellation diagram is what? The orientation of the your signal, in particular modulation scheme. So by this PPT you can understand what is the constellation diagram. Okay, so obviously in 4 PSK, QPSK your baud rate will be half because you are transmitting 2 bits at a time. Okay, so these are the advantages, like bandwidth is only FB while we are transmitting 2 bits at a time. We are lower bandwidth too in multi-level modulation. Limitation means generation and detection are complex. So M array communication, again you can go for after the QPSK 8 array PSK system, 16 array PSK, it means 3 bit combination, 4 bit communication, you will be able to communicate. So bandwidth will be reduced. Multiple bit data you can transmit now under the M array communication, but your intercellular interferences and probability of error, these will be more, complexity will be more. Similarly, some examples also you can do. If ASK signal gets the 800 BPS, then baud rate for ASK and QPSK. Obviously, in QPSK it will be half, 800 to 400. So this is the advantage. So this is from my side for this lecture. You can ask me, okay, if there is any confusion, okay, from my email ID or personally you can contact me. Okay, thank you very much.